to day 11 of our Power BI Developer Mentorship class. Today is day 11, and we are going to be looking at star schema. But before we get to star schema, there are some important concepts that you need to actually understand. It's very important for you to know this concept before you actually understand what a star schema is. Now, let's start with the concept of primary key. So what is a primary key? A primary key is a column, right, or set of columns in a table that, number one, uniquely identifies each row. It cannot be empty. That means a primary key cannot be null. It's not possible for a primary key to be empty or null, right? Now, a primary key cannot have duplicates. So these three things are very important when we are describing primary key, right? It must be unique, right? It means that for each row in a table, the primary key must be unique. There must not be duplicates, and primary keys cannot be null, right? It cannot be empty. So take a good example of what you are seeing on my screen. You are seeing a table in a school that consists of information about students, right? You see the student ID. The student ID there is the primary key because it is the ID of the students that uniquely identify different students, right? So one student ID. You see the name of the student on this table and you see the age. All those ones are what we call descriptive attributes of a student. So a student with ID 1001, that student has a name, they have a gender, they have their age, and every other attribute that describes each student, right? But the main thing we are discussing here now is the primary key, which is the student ID. Student ID column you're seeing here is the primary key for this table, for this student table. Okay, so it means that two students cannot share, they cannot share one ID. It's not possible, right? Okay. Now the foreign key on the other hand, is a column in one table that links to the primary key in another table. Now, if you look at the two tables you are seeing left and right on my screen, you will see students, the student table that has the student ID and their name. And there's another table called the enrollment table that now has the enrollment ID, the student ID, and the course name. So you will see that the student ID is a possibility that the student ID will be duplicated on the enrollment table because the enrollment table shows the enrollment of students. So it means that one student can enroll for several courses. So if you look at enrollments 1001 and 1003, those two enrollments belong to student ID 1. It means that as a student, I can register for mathematics, I can register for English, I can register for basic technology, I can register for what some schools call GES, some schools call it GNS. So I can register for as many courses as possible, depending on the what will be my what we call elective and core courses, for example, in a semester, right? So the students table you are seeing by your left is just a dimension table that only has information about students and their descriptive attributes about the student. The one on the right, which is the enrollment table, shows transactions, activities, operations, right? It shows the enrollment of students. So that student ID that you're now seeing inside the enrollment table, it's a primary key of one table, which is the student table. But when it gets to the enrollment table, it becomes a foreign key, right? And the thing is that foreign keys can have duplicates because one particular product can be brought several times. One student can enroll for different courses. Transactions can go on in a city multiple times, right? So things like city ID, student ID, product ID, store ID, all those things are primary keys on their own table. But when they get to a transactional table, like a fact table, they become a foreign key, right? So we use the foreign key to link to the uh, dimension tables, right? The foreign keys in our fact table, we use them to link the dimension table so that we can, get more information about the transactions that happens in the transaction table, which is our fact table. Okay. Now, what is the key difference between these two, the primary and the foreign key, right? So if you look at the primary key, there's uniqueness of a row, right? For the foreign key, it links to another table's primary key, right? Uniqueness, in terms of uniqueness, primary keys are unique and they are non-null, right? If you are dealing with data as a Power BI developer and you notice that the primary key is null, then you have to actually go back to the source and go and check what the problem is, because it's not it's not okay for the primary key to be null or to be empty, since it's a unique identifier that identifies something, right? A foreign key can repeat and it can be null, right? There are situations whereby a foreign key can be null. Let's say, for example, you have a list of customers in a dimension table, and you know that you might have 50 customers in your register, in your database, as in that you have onboarded to the system, but it might not be all the 50 that will buy, that will initiate a transaction with the organization. It might not be all. So it's very possible that when we run our calculations, we can see that it's only for 35 out of 50 that is actually transacting with the business, right? So it's very possible that a customer is not buying. So foreign keys can be null, right? It happens sometimes, right? We are not saying it happens all the time. Then in terms of the usage, primary key is used in the parent table. So we consider the dimension table as the parent table, right? Is the one that has the primary key, that has the descriptive attributes of the primary key, right? Now the foreign key is used in a related table, which we call the child table. Your fact table is referred to as a child table, while the dimension table is referred to as a parent table. Okay, now let's now go to the concept of fact table itself. Now, what is a fact table and what does it even entail? I know that most of these things, most of you have heard it before, right? But we are really going to get clarity on some things today. That is why it's important for us to be in this class. Now, a fact table stores measurable and numerical data, right? The fact of your business. So when we say fact is something that is quantifiable, something that we can quantify, right? For example, total quantity, total sales, total profits, anything quantifiable. Those are the business facts. We call them business facts, right? So it answers questions like what happened, right? So every row you see in a fact table is a business event or activity. For example, sales, somebody makes an order. So every row represents a business transaction or a business activity, right? Um, a fact table contains foreign keys, right? That are going that we usually link them up to to the dimension tables, right? So if you look at my screen, you will see a sales fact table. Now I want somebody, and I want you guys to respond very fast. I want somebody to identify the facts in this table for me. Mention some of the facts that you can see in this table that you're seeing on my screen.
Quantity sold, total sales.
and total sales.
Thank
Total
you.
sales.
Quantity sold and total sales. Yes, they are the facts that you can extract from this table, right? Now, can somebody tell me the dimensions that you can extract from this table? The dimensions.
The product key, the
Yes.
stock key,
Product and stock.
and the
Is that
and
the
the
only
date
two that are there?
and
As
the
Stock
date
key,
dimension.
stock key, and
And date key.
date key too.
So what are the dimensions that we have here? Can you measure the three that we have here? The three dimensions that we have here.
the date
Date
key, the
key,
product key,
product
and the
key, and
stock
stock
key.
key.
Exactly. Some people are mentioning two. That's why I have to say three, so that they can understand that the date key too is a dimension, right? Okay, let's go to dimension table, right? A dimension table stores descriptive information. For example, now let's go back to the fact table. That in this fact table now, this fact table has been, it has been well normalized that the only information, the only thing representing the dimension is their keys, right? Now, with product 101, all I can see on my fact table is product 101. How will I know the exact product that was bought? I cannot know the exact name of this product if I did not link it up with the dimension table. So although I'm saying product 101, but it is the dimension table that will give me information about that product key 101, right? That okay, this product it is Melo. It is the unit price is so price, right? It is in so kg. I will not see all of that information unless I go to the dimension table. I will only see this information if I go to the dimension table. The only thing representing my dimensions on my fact table, they are just the keys, the foreign keys. And these foreign keys are the primary keys in those dimension tables. But when they get here, they become foreign keys, right? Now, let's go to the dimension table. You see that the product key 101 now. I'm now seeing other descriptive information about that product key. Right? If I do not come to the dimension table, there's no how I will know that this product is t-shirts, the category is clothing, and the brand is Fashion Co. I would not know. Right? So that is why dimension tables too are very important. So they help us answer the questions who, for example, we are dealing with customers and you see customer 101 in your fact table. So it will answer the question, who is that customer? Right? You will see who that customer is on the dimension table by the virtue of the information that you will see that is describing the customer, right? So customer ID, customer name, customer age, customer location, and all those things, they are descriptive attributes of the customer, right? So I help you answer the questions who, what, where, when of a fact, right? Now, we also use dimensions to filter, to group, or label our facts. Okay, let's go ahead. Now, what's the key difference between a fact and a dimension, right? So, in terms of storage, fact table stores numeric, measurable, quantifiable facts, right? Dimension stores descriptive details, right? Now, for fact table, the kind of keys that you see there, you see foreign keys and plus the measures. I will still explain that later, right? For dimension table, you will say primary key. So it doesn't mean that in fact table too, we don't have primary key. We have primary keys in fact table also. In fact, we even have what we call composite key. We even have what we call surrogate key. We are still going to go to all of it and we go to more details about it. In terms of granularity, granularity has to do with the level of detail. Some people, we can also call it grain, the level of detail, right? Fact tables are always transactional, right? They show the level of events, right? Dimensions on the other end are business entities, right? In a sales company, you see procurement, you see sales, you see marketing, you see pricing, you see customer service, you see inventory, you see this and that. So they are the business entities, everything that is in the, how will I put this, in the company's daily operational processes, everything is linked to each other. So the daily organization operations, what they do, or maybe the procurement first go and buy the product, take it to the warehouse. The pricing department will determine the price based on their own pricing model. Then it goes to customer service. The customers will call them to make an order. Then the order goes back to the inventory department for them to take it out of the warehouse, and it gets to the final, and from them to logistics, who will now deliver the product to the customer. Blah 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 blah. So they are business entities, right? Okay. Example of columns that you can see in the fact table: quantity, revenue, profit, sales, blah blah blah. Dimensions, you see things like product name, store name, city name, location name, customer name. Those are the kind of columns that you see in a dimension table. Okay, now let's talk about what we call OLTP, the online transaction processing. If you remember that I told you guys that in the previous class when we were discussing, when we started the dimensional modeling basics, and I told you guys that understanding of OLTP and OLAP is very, very important because these OLTP systems, like the databases that carry the raw data, right? The way they are optimized for fast writes. It means that different uh, people can be using the same system at the same time, and one will not stop the other, right? So I give an example of the Uber app. That, for example, me and you, somebody else here, everybody here can order Uber at the same time in different locations or even the same location, and it will bring us drivers. So I don't have to wait till when your own order is done before I can now make my own order for a ride. No. So the way it works is that OLTPs, they are designed for operational purposes. Those kind of databases, they are designed for operational purposes. And the good thing is that they are well normalized. That is, in fact, what you will see in an OLTP is third normal form that we talked about last week. Is third normal form, right? That is that you will see different interrelated tables. They are in smaller sizes. And the good thing is that if you want to, if an update wants to happen, it's very easy when the tables are well normalized, right? That is an example, third normal form. When they are well normalized, it means that there is no room for duplication. There's that data integrity, and it also avoid what we call redundancy, right? And if they are because it is for operations, because it actually supports all those frequent updates and inserts, right? Because the databases. So let's take a good example now. In a banking system now, everybody has a bank app, right? You make transfers, you buy recharge cards. What do you do again? You buy data. What do you guys do again on the banking app? What do we do? What do we do? Transfer money, buy data, and so
Pay
many other
NEPA
things.
bill.
Sorry.
Pay NEPA bill.
Pay NEPA bill, whatever it is that you do, pay your bills in general, right? That you do. So everybody can be on the app, and at the same time, they can, interact with the app and do stuff on the application. Everything that you are doing at that time is going to a database, right? Those databases, we call them OLTP, right? So there will be different tables for different things. The first person that when the person opens the bank account, there's a table for that. If somebody changes their address, there's another table for addresses that can be linked with what's it called, with the customers onboarding table. So they are well normalized because they have to be in that way because they are not for analytical purposes, they are for operational purposes, day-to-day operations. So because we don't want a situation whereby when we put all the data together in a place and we now want to make an update, and the update will now affect the entire table that we have in our schema. We don't want that to happen, right? That's why in an OLTP framework, we usually apply third normal form, right? For example, look at the example that we have here. We have customer table, order details table, product table, categories table. So all of these tables, you see that in that OLTP diagram, they are going to be linked to each other. They are going to be linked to each other. That's the way it works, right? That's the way it works. So just hold on for me, guys. Hold on for me, please. Sorry, just a minute. Mhm.
Please, I don't know if it's from my end though. I can't hear Mr. Benga again.
I said you should hold on. That means you're not following. I'm coming, guys. This thing is not working. Okay, let's just continue. No problem. So the way OLTPs are, we represent OLTPs using what we call entity relationship diagram, right? ERDs. So ERDs actually is not actually for it's not actually for OLTP alone, right? ERDs can be used for OLAP also, that is a data warehouse. It can be used for that also. So ERD is just what we use to represent or communicate the framework or relationship between different tables in our, in our different schemas, whether it is in OLTP or whether it is in OLAP, right? So and now this is where I'm going to, where I'm actually showing us, telling us about OLTP and OLAP is that as a Power BI developer, you are not actually meant to be connecting your Power BI to OLTP. No, you are not supposed to be doing that. You are supposed to be connecting your Power BI to an OLAP because OLTPs, they are designed for operational purposes. It is OLAP that is designed for reporting and analytics. So I see a lot of people make that mistake. When they are looking, when they want to build a new data product, like they want to build a new report or dashboard, they are going to be connecting to the OLTP, and you now see like 30 tables, and you will now see them struggling. They have to now start doing a lot of merge. Those things are not sustainable, and they are not even maintainable because at the end of the day, it will get to a point that it's now become more complicated than you can imagine. Right? So as a Power BI developer, you are meant to be connecting to a data warehouse, not not OLTP. OLTP is meant for just day-to-day operations of the business. It's not meant to be somewhere that because it means that you have to be doing a lot of, well, you don't even know what that means. You have to be doing a lot of joins. Join here because tables are interrelated to each other, as in the kind of normalization that is applied on the OLTP is stored normal form. So it doesn't make any sense, and it's going to really stress you to be connecting to an OLTP system instead of OLAP, a data warehouse, right? So OLTP is good for transactions because it ensures consistency and it's efficient when you want to insert and you want to update. That should not be your go-to while building a new report or dashboard. That should not be your go-to place. So please, let's have that in mind. Now, let's now go to OLAP, which is the data warehouse. It's called Online Analytical Processing, right? I told you that this one is meant for what? This one is meant for reporting and analytics, right? Now, in data warehouse, what we use is dimensional modeling, right? Now, because dimensional models are fast for querying and it's easy to report. Now, the data in your data warehouse, your OLAP, and the data in your OLTP, they are the same data. It's just that one is optimized for daily operations. The other one, OLAP data warehouse, that one is optimized for reporting and analytics, right? So it's the same data, but the way they are being structured is different. One is in third normal form in terms of normalization, right? The other one, right, is either it is a star schema or it is a snowflake schema, right? Now, it means that in a dimensional model, let's take star schema for example. a star schema, what we usually have is fact table and dimensions, right? And we now have all the dimensions connecting to the fact table. Perfect. No issues. Now, those dimension tables that you see in a star schema, they are denormalized, right? They are in denormalized form, right? They are not normalized like what you will see in an OLTP, right? Like what you will see in an OLTP, they are denormalized, right? The fact tables that are in a star schema, those ones are usually normalized. So you have to really get the difference between the data warehouse in terms of schema and the OLTP also in terms of the schema. What we call it in the OLTP is normalized schema. We call it normalized schema. Or you say your OLTP is in a normalized third normal form structure. So it depends on the way how you want to put it, how you want to put the sentence, right? But in data warehouse, we use dimensional model, and it's in different variations. It's either it's a star schema or it's a snowflake schema, right? So in a star schema, just imagine a star. So the fact table is in the middle of the star, and at each of the edges, you are seeing the fact table at each of the edges of the star. So that is the way a star schema is structured. A snowflake, on the other hand, the snowflake schema, on the other hand, is that instead of, if you look at the star schema where we said that dimension tables are denormalized, in a star schema, what happens is that we normalize the dimension table. So for example, now you can have something like product table, product category, subcategory table, and product category table, right? You see that hierarchy, that level, right? We'll break the table down, right? For example, now you can have a customer table. That customer table has location. You can have another table that is called location that will link to the customer table before the customer table will now link to the sales table. So that one is a snowflake schema. When you normalize the dimension tables that you have in your dimensional model, that is a snowflake schema, right? So in a star schema, the dimension tables are denormalized. It means that on the customer table, you will see every information about the customer, their name, their first name, last name, where they live, their age, anything about them you will see on that table. In a star schema, a product table will have product ID, product name, product category, subcategory, product size, unit price, everything about product will be on that table. But in the snowflake, we are going to break, we are going to further normalize that product table. That's when you now see something like product category, product subcategory, and product table. Do we understand the difference between OLTP and OLAP and the variations of a star schema and a snowflake schema? Is it clear to us now? Let me know if it's clear to you or it's not clear, please.
Yeah.
Mr. Benga, please excuse.
Yeah.
I don't want to cut you short.
Yeah, please go ahead, please.
I'm trying to explain that the data warehouse and the OLP is the same thing.
Yeah, it's the same thing.
Okay.
Same thing. Yes. The same thing. So, is there any question before I go ahead on this part? Okay, looks like it's clear to everybody. So now that we understand all of this, it's not as if I cannot jump into star schema and just open my Power BI and start doing stuff. But I want you to just get the basics of these things so you understand the differences, right? That's why you see that as a Power BI developer, it's important to actually know SQL. It's one of your core toolkits as a Power BI developer, because some companies don't have data warehouse. Mr. Show and Bankole, yeah, they can tell me I'm lying if I'm lying. Some companies don't have. What they have is OLTP. So you now have to write SQL queries that will now join different things together to give you one table. Did I lie, Mr. Bolonjo? Did I lie, Mr. Bankole? Or some complaints, what they call
even company that has itself. I think I can remember that there was a project that I was doing at a point that they even have all the system, but they don't even structure their data in a data warehousing platform. They just combine tables, So yeah, what you are saying is very, very valid. And I think someone also said it earlier now. He said you just do Excel and so it's still part of what you are saying. Yeah.
Okay, thank you. So in fact, I even read some books and I heard from some of my colleagues that some companies, what they actually call what they refer to as their data warehouse, their OLAP, is actually a copy of their OLTP. Like there's no ETL done, there is no restructuring, there is no joins and combination of things, there's no merging, there's no aggregation done, in their ELT framework. They just copy the same thing because they don't want it to connect to the same place that data is writing into. So they just copy. So what they call their data warehouse is just a copy of the database, like their OLTP. There's no, there's no design. It's not built in a way that can be used for reporting and analytics. So know this and know peace. So that when you get to organizations and you see what they have, you can tell that what they have here is OLTP. They don't have OLAP. You understand? There's a way you will know because the way data warehouse is being structured, right? It's that is in a star schema or in a Snowflake schema. But when you start seeing 30 tables and they are all normalized, then you will know that this is an OLTP. But ideally, for a Power BI developer, right, you are supposed to be working with a data warehouse, right? But you can also have access to the OLTP because there are some. In fact, you're not even meant to be doing that because there are different ways that this works. So there are some sometimes that same copy of the OLTP, right? You will have that one, and you now have another one that is in a data warehouse structure. So the copy of the OLTP, in case you want to now, recreate some tables by yourself. Maybe you are doing some kind of reporting, and you now want to maybe you want to use common table expressions to, bring in a new table, to create a new table. That means you have to write queries that will now join different tables together to now, so it's that table that you now use and create your report. So that also happens, but in a place that things are well structured, right? Your data warehouse should answer, in fact, 85% of all the business questions, right? The way that data warehouse the way it should be structured, it should be able to answer almost all the questions that stakeholders are because of it means that one data warehouse, finance can use it for their own reporting, sales can use it so everybody can be using that same warehouse for different reporting depending on their own context and the way they view things, right? Now, although this is not in my slide, but I will say this. There's another concept that I want to explain. When I was explaining the dimension tables, I did not explain it. We call it conformed dimensions, right? Conformed dimensions. So what does that dimension? Why is it different from a dimension table that you used to know? So conformed dimensions are dimensions that can relate with every fact that we have in our schema. So for example, now you have the finance department, you have sales department, you have marketing, you have customer service department, and we have dimensions like products, like customers and co. Now, when finance is reporting about customers, when finance is reporting about products, when they are reporting about locations or warehouses or stores that the company has, the dimensions should be able to relate to all the departments. So it should not be that the product lists and product IDs that the finance is using is different from the product table that the customer service or sales department are using for their own reporting. It should not be like that, right? So dimension table should actually conform. It means that it should be relatable to all the business entities in an organization. So we call that conformed dimensions. Is that clear to us, guys? Ladies and gentlemen,
Yes, sir.
is it clear
Yes,
to
sir.
us the concept of conformed dimensions? Now, why are we even talking about dimensional model in the first place? Why is it even important? Because I heard somebody was saying last week that why are we learning normalization? Why is this important? Don't worry, it's going to expand your knowledge about your data model. You know, when you are building models now in Power BI, you have a better understanding because you have a very solid background of dimensional modeling, right? So before the advent of Power BI, before Power BI even came into being, right, dimensional modeling has been what has been used in data warehouses. When they are building data warehouses, what they use is dimensional model, right? So it's important because it's optimized for reporting, and I've said that before. It's easier to understand, I mean, for business users, right? And it's faster for query. If you want to query, unlike imagine you are querying OLTP now, that you have to join different tables, and it can become so complicated, right? In fact, you even see tables that are not directly connected to each other in an OLTP. You will see them, right? So, but for dimensional model, like in that dimensional model structure, it's easier to query data because of that simplicity that comes with dimensional model. You have the fact, you have the dimension. Very simple, easy to understand for business users, easy, faster for queries. Do we understand? Now, what's the key difference between OLTP and data warehouse? Purpose, day-to-day operations. For OLTP, OLAP, reporting and analytics. For structure, is within third normal form. This one is either in a star or in a Snowflake schema for data warehouse. Tables, many small related tables, facts plus dimension tables for OLAP. Design focus for data integrity for minimal redundancy. That's the design focus for OLTP. But for data warehouse, for query speed and for simplicity, right? Example of an OLTP system, we use it for placing an order, right? For OLAP, analyzing monthly sales. Now, you see that Power BI works best with dimensional model, right? Power BI works best with what? Dimensional model. Although the one that Power BI works well is that we all know is the star schema, because star schema is considered as the best practice in Power BI. And why is that? It's because it improves the performance, right? Especially if you are dealing with large data sets, it makes DAX calculation very easy. Yesterday, I had a conversation with Follow Show, and we were saying that that DAX does not have to be complicated. DAX does not have to be too bogus, and you have to be cracking your brain to write DAX expressions. No, you don't have to. If your model is very good and is well structured, it makes the DAX very easy, right? Now, another advantage of star schema is that it makes it easy for you to slice and dice, right? It's very flexible for your slicing and your dicing. Then it supports relationships. For example, we have one-to-one, one-to-many. Although many-to-many is not actually good for efficiency and for querying, it's not ideal to use many-to-many. But we are still going to talk about that in details anyway. When we get to cardinalities, when we get to different type of relationship And Isaiah will also take us through what is called storage mode, where we will talk about import mode, not just talking about import mode. We are going to really go into the details of import mode, right? We are going to talk about direct query, and we'll talk about what's this last one, composite or dual mode. We'll talk about those three as the basics. Although there are more, we have more than three now, but we'll talk about those three for a start. I'm not talking, we'll go into details about them. Like, we look at their limitations, what they can do, what table do we set as import, in what scenario do we use a direct, even the different models. We have direct query model, import model, and dual constant model. In what situation do we put all our tables in import? In what scenario do we put all our tables in direct query? All those things. Where do we mix it up? And what is the efficient way that we have a mixture of both the import model and the direct query model in our schema? So all of these things, we are going to go into the details of them. So is it clear at this point, or we have been discussing this morning?
Yes, sir.
Yes, sir. Yes.
Thank you. Mr. Abdul Samad, you have a question.
Yeah, good evening, Mr. Bengulo.
Thank you.
Yeah.
Can you increase your volume, please?
Yeah, can you hear me now?
Yeah, clearly.
Yeah. So my question is like can we have more than one fact table for a star schema? And if we have like okay, let's say 1, 2, 3, 4, 5 fact tables, will it not affect the performance of our data?
So it does not affect the performance of your data. It all depends. Although it's not actually good to have two. It's confusing anyway. It's not actually advisable to have too many fact tables, right? The
Okay,
ideal
but
star schema is
sorry, okay.
should have one table that relates to all the dimensions.
Okay, but what if you are
But there
working
are
with a
situations
large data
whereby,
set? Okay.
sorry.
You can go on. Like what if you have like like for instance, when I'm working, like I noticed that for what's it called? In our data, what's good in our database, we have there are like more than one fact table there, and somehow the performance is not that um like for me it's not really effective like that. So that's what I'm asking. Like okay, like won't it affect performance? Because I noticed whether we like it or not, in some instances we would have more than one fact table for a larger data set, and so that's what I'm asking, anyways.
Okay, so this is the thing, eh? Power BI is a little dicey when it comes to performance. So sometimes when you are building a schema or when you are building a report, sometimes it's very dicey to choose between whether you are looking at it from the angle of performance, right? Or you are looking at things from the angle of performance, and what's the second one? From the angle of the level of details that you want to see. Like you have to choose to like make that decision. But if there's a possibility that the information on that second fact table or that third fact table, you can find a way to merge it on the first fact table, that they will serve as additional columns, and they will still maintain the same conformed dimensions. Then I think it's better to do it that way. But if it's not possible, if you are bringing in another fact table, well, the more tables you have, the lesser your schema will be optimized. So it all depends on the situation. Well, I will not say it is good, and I will not say it is bad. I want the others to also contribute to this. Follow Show and Bankole. And any other person that wants to contribute to this.
Sorry, the contribution now is on. Is it on
Having
the
more than one
facts
fact table in a schema.
in a schema? Okay. So I think it's possible. Yeah, it definitely is possible. But what about in terms of optimization, right? So I think there's something that I realize with Power BI is that a quite number of us, when we are building our model, right? So maybe I don't want to share this, but I will try and do
Please don't share
something.
if it's not something you can share.
Yeah, it's fine. But I just feel like a lot of us, when we are building model, right, especially in the Power BI environment, we tend to just want to build our models just once. I'm going to show you guys. I will just show the model part. I don't think that should be a problem. if I can share. But I just feel like sometimes you might need to first understand. Once you understand your models very well, right? Once you understand the model, you can actually segment your models. But you guys will not understand what I mean unless I show you. So that's why I said
before
that.
you share screen, let me give an example of when something like this can happen. Can you hear me, Mr. Absalman? So let's say you have different dimensions:
Yes, I can.
products, your date dimension, your location dimension, and you now have two fact tables. You have your sales table, you have your inventory, right? So inventory and sales, no, they are not the same. Like they are two different business entities. But the good thing is that for consistency to happen and to avoid redundancy and to make sure that there's no complications in your schema, that's why it's important to have a conformed dimension, that all the dimensions can connect to inventory, right? And they can also connect to sales. Do you understand?
Yes.
The same dimension table
Yeah.
should be able to
Understand.
connect to the, whether it's 2 or 3 or 4 fact tables that you have, they should be able to connect to them. And that's where the concept of conformed dimensions come in. Do you understand?
Yeah, I
But where it
understand.
can be complicated now is that imagine that the different fact tables now have their own different dimensions. Is it clear?
Yeah, it's clear.
Okay.
So if they're going to have their own different dimensions, it may be like
It will because it will,
it's going to be complex somehow.
it will become complex and they will not be able to relate well.
Exactly.
Sales
Yeah, I
and inventory
understand.
will not relate well. That's why when you always need to ensure that there is conformed dimension.
I understand. Thank you.
Yeah. Thank you, sir. Mr. Fernand, you can share your screen now.
Okay. I'm coming. Okay, I'm coming.
That's a very good question. While he's sharing his screen, does anybody else have questions?
Okay, so can you see my screen now?
Yeah, we can see your screen.
Okay, so I think when it comes to modeling, and one thing I think I realized that most of us, maybe we don't know, right, is that sometimes when we have models like this, we just tend to want to build our models in just one single models, right? Everything just like the way it is showing here. But we don't know that, okay, we can actually break down some of those models into, even though all these tables are kind of related, but in some kind of way, this might be more complicated to you. When you look at it and you just see all these diagram, what is all this? So sometimes you can actually break them down. You can see maybe this is just relating to this one is relating to this one. You can break down your models into different sections of, yes.
This one you're showing now is, to me, looking like a star schema, a snowflake.
Yeah, definitely. It's a snowflake.
It's a snowflake, are you okay?
Yeah. So, but what I'm just trying to explain here is that sometimes a lot of people does not know that they can break down some of these, you can have one single report and you can have, different models breaking down, into different pieces to create your report. And it will be more optimized than just trying to build everything in just one single this is the default one actually, but you can break it down. And another thing is that, please, most of the time when you are trying to build your model, don't go to set. Let everybody try to always do this. Go to settings and disable automatic relationship, because sometimes automatic relationship will create relationship for us at times that by the time you want to start creating the relationship yourself, you will now be finding it that one will be telling you that, oh, there's a relationship between these two tables before. Now you'll now be wondering that, when did I created this relationship? You will have forgotten that it's the automatic relationship that you have created that is actually affecting that. So it's better you create or define your own relationship. And that is what I did here in this project actually. So most of the relationship, I'm the one that defined them. You understand? So it is more simpler that way. So yeah, when it comes to multiple fact table. So multiple fact tables in a model is what they call galaxy schema. I don't know whether you have heard of galaxy schema before. So galaxy schema is a kind of schema that you have
So
many.
it's same thing as constellation, the constellation schema.
Yeah, I think so. Yeah. So yeah.
Okay.
So and in another scenario where that comes in. So let's say, for example, now is a sales. So for example, now maybe you're in a manufacturing company. Some company might be, they might have a record for sales, and sometimes when they sell goods out, maybe a particular product, there might be a return of some products. You understand? The company have already said that, oh, they make profits, but at the end of the day, there are some returns on some particular product. Now, how do they want to calculate their revenue when there are still some some returns on a particular product? So they have to, so what they do is that sometimes they might have a separate table for for their sales, and they might have a separate table for their for their return. So in that scenario, you might have a multiple fact table in your dimension, in your models. I don't know whether you guys understand that concept now. So it is possible that multiple fact table can occur. You understand? But one thing is just that, please, let's try to understand modeling itself. If you don't understand the concept of modeling, you will have a lot of, I think Uncle Benga have already said it already. You have a lot of difficulties. Let's try to understand that concept of data modeling, dimension, fact table. You understand it very well. See, this work that I'm showing you guys here is just a single table. It's a single table. When I got the files, I'm the one that modeled the data into different dimensions, right? So please, I think that's just what I will add. Maybe Abdullah will have more to it.
Is Abdullah here? Okay, maybe it's not available at the moment. Okay. So I don't know if we should continue. Do you want us to continue, guys?
Let's continue, sir.
Let's
Yes,
just
sir.
like if I enjoy the class, eh? Abdullah says, let me open our Power BI file.
Okay, good evening.
Well done, sir.
Yeah, I wanted to ask Mr. Sima what environment did the fact table occur. I know that that there are many cases of having multiple fact tables in warehouses, which is a good thing. I don't know for Power BI, because I'm also new to using Power BI. So I wanted to, because I know that you said there's going to be complexity around having multiple fact tables. I'm not sure if I get that correctly, but I know.
So what I said was that you see, the thing is that it depends. I said sometimes you have to make a decision between whether you are looking at your report from the angle of performance, or you're looking at it from the angle of getting all the details you need to get out from your report. If you're looking at your report from the angle of performance, right, it means that you will make sure that you minimize as much as possible, whatever you can minimize, even in terms of data that you are bringing in, right? If you're looking at it from the point of, okay, I want to see I want to see everything, see all the details in my report, then there's no big deal in having multiple fact tables. I'm just saying that the lesser information you have, the more optimized your report is going to be. So it's kind of dicey. Do you understand me now, Abdulaziz?
Yes.
So that's why that question that Abdulsamad asked is not a yes or a no question. It depends on what are you reporting about, and but from what angle are you looking at it from? Do you understand?
Yes, I do.
Okay. Thank you. Any other person? Is it don't worry, by the time we start the practical, it's going to start making more sense to you. Did I model this data already? I was wondering, say, hey, when did I model you? Can you all see my screen? Let me delete this one that is. So let's create a star schema now. Practically. Okay, that English correctly. So you see all the dimensions that we have in now. These are our file. These are Power BI file.
Please, can you zoom out?
Sorry?
Can you zoom out, sir? We are unable to see it very well.
Don't worry, you will see it clearly. Just hold on. Is it that small?
Yeah.
Are you serious? So I'm not going to have these ones because we just use them in our Power Query. I can even go and can somebody do you still remember what we did in class the other time? Do you still remember including refresh and this thing? Do you still remember, guys? Was
Yes,
that not
sir.
day four that we did that? Yeah. So this is an example of a star schema. You see the sales table is in the middle. Is it bigger now?
Yeah. Thank you, sir.
Yes, sir. Which one is this query? One sec. Oh, I don't need it. It's not part of. You just need to do example. So these are our tables. Did I miss anyone, guys? Please tell me. This is all our dimensions. 1, 2, 3, 4, 5. These are the dimensions that we have. Yeah, I think so. This one is a what's another column? This one is a parameter. It's not part of this thing. Okay, so let's start connecting now. So what will I use and connect segment and sales? Bernard.
Segment ID.
Segment ID. Is there anything like that? I'm not seeing segment ID. What's going on? Go back to my Power Query. Something is not right there.
Yeah.
Is this the original table? Oh, this is not the original table I'm supposed to use. Sorry. I won't confuse everybody. Okay. Yes. Okay, good. This one should go and sleep somewhere. Segment ID and segment ID here, right? So
Yes,
giving
sir.
us a one-to-many relationship. What does that mean to you, Bernard? What's the meaning of one-to-many?
That means in the dimension table we have a unique ID. Then in the fact table there are some duplicated ID there. So that unique ID.
Is that the only reason why it is giving us one-to-many?
Yeah, that unique ID means we do not have any repeated ID there. But for this for the fact table, we have repeated ID there.
Okay. Relationship can be active or inactive. But I teach you guys what's this topic of? Role-playing dimension. That's when I will now explain, why we might have relationship inactive. I will explain it to us. All this assume refresher integrity and apply security filter. When we get to RLS, I will show you. So let's click on save. So now we have connected these two tables together based on their similar keys that they have, the segment ID, right? So what we call one and many is cardinality. So the cardinality here is one, and cardinality here is many. It is one here because of the uniqueness, right, of the IDs in this segment table. And when we get here, when we get here on the sales table, the segment ID, you know, it has duplicates. That is, one segment, in one segment, there have been different transactions going on in a particular segment. So even if there is uniqueness in the sales table, each segment appear only once. The moment one segment, you know, has duplicate record, it becomes many cardinality. It's no more one again. It becomes many. So far is a duplicate, right? So let me ask you again, Bernard. In what scenario can we have a one-to-one relationship between the sales table and the segment table?
Okay, so the scenario where we can have one-to-one relationship
Yes.
is when the dimension table is unique and also the fact table also has a unique ID. So there's no duplicate in the fact table and there's no duplicate in the dimension table. So that's
So
when we have
normally in the dimension table, there's no duplicates in the dimension table already now.
yeah, also if there's no duplicate in the fact table for the segment ID, so that means we are going to have a one-to-one relationship.
Okay, thank you. So
Yes, sir.
customer ID here to customer ID here. Also one-to-many relationship. Now, so there's something I will still discuss with you guys here. This cross-filter direction. I will still explain it, but it may not be today. Maybe when we come next week Sunday. Ship mode ID with ship mode ID. Perfect. One-to-many relationship. What again? Product ID to product ID in the sales table. One-to-many relationship. Recategory ID with recategory ID here. That is one-to-many. And always check here that you're selecting the right column. So ID here, right? And what again? Location ID with location ID here. One-to-many relationship. So now we have built a star schema. You see that at the different edges of the star, you have the dimensions. And you have the part table in the middle of the star. Any questions as we come to the end of today's class? Any question?
So, Mr. Benga, I have a question, but it's about relationship, but it's not really about this one-to-many.
Please ask, so that every other person can learn.
Okay, so the question is that I'm presently working on a project. So I'm trying to connect my dimension table to my fact table. So I'm getting a one-to-one relationship. But the data is going to be updated on a daily log. So, and I decided to use.
What do you mean by daily log? What do you mean by that?
Yeah, that is maybe weekly or daily. Those data will be updated in my facts table. We might have a duplicate later. I think you understand that. So we might have a duplicate later, and presently it is one-to-one relationship. So I tried up my possible best. I made some research. So then I later said, okay, let me just use the one-to-one relationship, and then I documented it that maybe in the future, if there is a new data updated to the fact table that makes it that added duplicate to it, then I can later come back and change the relationship. So the question now is that won't I have a problem maybe in the future if I say, okay, I'm using one-to-one now, then maybe later in the future if there is a duplicate, then I can later say, okay, let me go and change it back to one-to-many relationship.
Whether it's automatically change, Abby?
Yeah.
I'm coming. Will it automatically change? Let me think about it. Do you have to be the one to go and change it manually? Please let me do that research.
Okay.
I'm coming. Okay, I think you have to go and manually do it.
Okay, okay,
I
sir.
think you have to go and manually change it, yes, by yourself.
Okay.
I don't think it's going to be. If at the beginning what you had was 1-to-1, and now you now have the foreign keys, they now have duplicates. I think you have to go and change it manually by yourself.
Okay, sir. Thank you, sir.
You have to go and change the relationship type by yourself.
Thank you, sir.
So I don't think Power BI used to automatically update cardinalities of relationship between tables. No, I don't think so. I don't think so.
Also, I
Yeah.
have a question also. So,
Sorry, what do you say now? Sorry, I didn't hear you very well.
I said I don't think Power BI automatically changes the from 1-to-1 to 1-to-many by itself.
No.
Maybe it automatically detects that is man 1-to-many and change it for you. I don't think so.
No.
That's what I was saying. I think you have to go here manually and now go and change it from here. The cardinality here. You now change it to 1-to-many when that happens. Okay, continue, Bernard.
So does it notify maybe the administrator or something like this?
Sincerely, I don't know. I've not faced that before. I don't know.
Hello.
Hello.
Yeah, sorry. Abdullah here. So basically, if something like that changes, if you have used that column or that something in a visual, you start seeing some kind of errors. I still face something like that today myself, and only for me to notice that because I updated the report, so it has changed the cardinality and some other things. So then you now have to go and rechange. You have to do it yourself again. Okay, change it from this to this, or you do cross what's this thing called? That cross security something that you do that filters both tables and the rest like that. So, but one way to know that something has changed in your model is when if you have used those tables or anything from any of the table inside a visual, there's always going to be a change. It's just going to show an error and tell you to start detecting relationship again or something like that. That's my own experience.
Okay. Thank you.
Okay, thank you, sir.
Again, ask questions.
Sir.
Yeah.
I have a question, sir.
Mr. Jami, Abi.
So, yes, sir.
Okay.
So, good evening, sir.
Yes, sir.
So, I encountered this situation recently, which I still haven't been able to solve it yet. It's about this relationship.
Go ahead.
So, in a situation where not all the dimensions table have relationship with the fact table, right? But that don't have relationship with the fact table, they happen to have relationship with another dimension table. I believe that is snowflakes, right?
Yes.
So, but then, yeah. So I established that relationship between the two dimension tables.
Okay.
But then I have to make calculation between that one that I related to another to another dimension table. Yes, between that one and another fact table again. I mean another dimension table that is related to the fact table. I don't know if you are following me, sir, because the way I'm saying it myself,
so you want to bring information from that one that connected to another dimension.
Yes.
In your calculation, Abi.
Yes, I want to bring it
what is happening
so that it works with another dimension table now. But now I'm having a relationship problem between them. So
this is what
before
we usually do.
That, I used to think.
Okay, continue.
Okay. Yeah, before then I used to think that once all my tables are connected together in one way or the other, they are supposed to just work together like that. Until then, so I got confused that at least all of them don't connect now. So why should I still be having a relationship problem now? So till now I asked my boss, but For some reason, he just wants me to figure it out on my own. So I don't know. I still left it. I just had to focus on other things, other ones, so that I can get back to it later. So because there's a lot of reports to be made for now. So I just, sir. So what do you
Does someone
think I
want to
can do
answer
about
in
that,
before
sir?
I answer?
Low battery, please charge.
Does someone want to answer him before I? So I follow on show and
Okay, for me, when I have stores like this,
Mhm.
there are times that I will just create. I myself will find that relationship one way or the other. Take for example, I'm working on, let's say, attendance of staffs, and I want to link the attendance of staff is from a different system, right? And the staff information, that another staff information, I want to now link that information that is on the attendance. I want to link it with something that with the original HR file that will be given to me. Now, later, there's a relationship between them, which, for example, let's say the staff ID, right? So, but later, I got to know, okay, I want to pick the division, or I want to pick the branches that this staff are in. It's not working. What do I then do? In my own case, I will create a single. I don't know even if Mr. Benga have talked about it because I was not really present in this class, but I usually create a single modular table. For example, so that table, the only thing that is in that table is one column that has only the branches. Or for example, a column. So is that column that I'm going to use to now connect this table to this table. Since in the original instance, the two tables are connected though, but that thing that I'm bringing, for one reason or the other, is not working. So what I used to do is I will create a single modular table. So in that table, all the branches that I have for my company, they're all in that table. So now that table can easily connect to the staff details. That table can easily connect again to the what's it called? To the attendance side as well. So those are some of the things that I do. You see the way schemas work, or the way tables work, or modeling work. Sometimes you have to think outside the box. You have to just open your head, like, okay, let's do it this way. You keep on doing it this way until you get one exact one, because sometimes the things, they might look as if they are connected. This one happened. What I'm talking about is still today. It's just this evening. I just solved it. I've done these things for like a year, just because one person said, I want to see this one again inside this report. Okay, I tried it the normal way. It did not work. I kept on trying until I got that hack that I just brought up now. But it might work for me and might not work for your own this thing. But I'm just giving an example of something that I do that usually works for me if I'm in that position. Thank you, sir.
Okay, thank you. Is there any other person that wants to contribute to this?
I'm sorry to interrupt. I just want to let everyone know that the attendance has been dropped. The form is on the group chat and in the chat box. So please fill it on time.
Okay, so I'm going to just give like two suggestions on what one can do. So there is a particular suggestion that I would not really advise you to use because of optimization. So what we usually do in that context is that, well, what I usually do sometimes is that I usually come here to change this to a cross filter direction, between those two dimension tables. All right, and also do that to connect to the sales table too, but it's not actually ideal for optimization, right? So these are what you can do. There's what we call transverse. We can use DAX to transverse the relationship, right? So what that means is that, for example, you can use, maybe you're writing DAX, you can use some X and summarize. Some X is an iterator, right? So you use some X, you use summarize,
Yes.
you reference. So this is what you are going to do. So this is what you are going to do. So, for example, now in a situation where we have what we call something like product, I was saying this a lot, that A good example is products subcategory and product category. So in the case that you now have, maybe you have product category connected to products, and product is now connected to sales. So what you would now do is that, when we summarize, when we use summarize, you can reference columns from two different tables when we are using summarize, right? So you can have the facts table. You can now call in the product, a column from the product category, right? And probably call another column from another, maybe from the product table, right? Or let's just keep it simple. You can say SumX summarize, then you are going to reference a column in that hierarchical one, the one that is connected to the table that connects to the sales table, right? I will share you an example in the chat section now so that you can better understand what I'm saying. So look at the one I sent to the chat section now, this class. You will see SumX summarize, then the fact sales table, then you reference that's product category. So what you are doing is like you are summing up the amount of the total sales for the product category, right? Even though that product category is not directly connected to the sales table, it's connecting to the product table that is connecting to the sales table. Do you understand? So we call that using DAX to transverse the relationship. Now, another thing that you can do is to actually bring those two tables back to a denormalized form. So it means that instead of having product category different from products, what you do is to bring in the information in product category to the product table, so that it will only be one table of dimension that will be connecting to the sales table. Is that clear?
Okay.
So maybe you can maybe you are going to do a merge in your Power Query, so that for every product it will return the product category. Star schema is always in the dimensions are always in a denormalized form. So to make it simple for you, you can also do that, right? That is like option 2. And option 3, what we usually do in option 3 is that we usually this DAX function called related, right?
Yes.
Yes, you can use related, but the issue with related, I'm looking for a way to explain how you can use it related though. Looking for a way you can use it. Okay, so you can use related DAX function, right, to actually still make sense of so let's say you want to filter something. Maybe you want to say when product category is equals to something, right? So you can use related, you can use calculate, right? That calculate will always transition something to the proper filter context. So I'll give you another example of that. I'll put it in the chat section also, so you can see what I'm saying. So, but I think the best way is to actually denormalize it. Do you understand me, sir?
Yes, sir.
I think the best way is to denormalize it. That's the simplest way to solve the issue. So you know have that hierarchy, the other dimension table. You won't have it again. Like you won't need that one again because you already denormalized. Is that clear to you?
All right, sir.
Yes, sir. So do that in your Power Query, denormalize it, reload it back again, then you can do whatever you want to do with it. You can do both the product category and the product in that one table. Is it clear?
Yeah, thank you, sir.
Yes, sir. Any other question? Any other question? So in coming classes, I told you that we are going to be talking about storage mode. Talk about storage mode. We'll talk about different storage models. Then somebody is coming next week Sunday to talk to us about Power BI interview question and answers. So the person is an expert and somebody that I respect him very well. Like he's a he's a guru. So he's coming next week to come and do Power BI developer interview question and answers with us. If time permits us, we might still do something, but I don't know how his section will take. I don't know how long it's going to be for a section. But if that's the only thing that we can do for next week, then I think it's fine. Then in coming weeks, we do the other. Then we move to DAX. DAX is the next thing that we are going to now. So we are going to start with row context and with filter context. Those are the way we are going to structure a DAX class. ASD.
Okay, you're talking about, thank you very much for the class, first of all, and I really enjoyed today's class. Thank you very much.
Yes, sir.
God bless you.
Yes,
Please,
sir.
you're talking about the next week class. You initially mentioned we are going to have our test next week. I want to believe that God has touched your mind. You have removed that exam.
Is your test next week?
You said 18th.
After the guys section, we'll have your test.
Yeah, I thought God have touched your mind. You have forgotten
No,
about that test.
So the guy was supposed to come today for his section, but I didn't remind him on time. So he said, that he's not prepared. I should make it next week.
Okay.
So, but I will tell him to just make everything.
The test.
You can also leave the test, sir.
Another week now. So we can have the class. It's going to be expensive and
okay. Let me stop the recording so that we can talk.